Chapter 9 is on Lewis theory. So chapters 9 and 10 deal with what molecules actually look like. So let's jump in. So Lewis theory is a simple bonding theory and was invented by Lewis. And it emphasizes those valence electrons that we talked about in the last chapter. So understanding valence electrons will help us understand bonding. And using Lewis theory, we can draw models. We call them Lewis structures or electron dot structures or Lewis dot structures. That's going to allow us to predict several properties about molecules like stability, shape, size, polarity, that sort of thing. So let's talk some background about why atoms bond together. This all goes back to energy. So chemical bonds form because they lower the potential energy between the charged particles that compose atoms. So, if the potential energy of the bonded atoms is less than the potential energy of the separate atoms, a bond will form. If you wanted to work through and calculate that potential energy, you need to think about how the two positive nuclei will repulse each other, how the electrons will repulse each other, and how the nucleus and electrons are attracted to each other. If you can account for all of those, you can understand bonding. We have three types of bonding. We've talked about the first two in some depth already. There's ionic bonding, where you have positive cations and negative anions that are attracted to each other and form solids. There's covalent bonding, where molecules or atoms share electrons with each other and then are held together by things called intermolecular forces. And then we haven't really talked about metallic bonding, but that's bonds between metals where the electrons are kind of shared between all sorts of different atoms. Okay, in order to understand Lewis theory, we need to talk about valence electrons. If you remember, we talked back in chapter 8 about how the column number on the periodic table will tell you how many valence electrons a main group atom has. So if you look at the top of the periodic table, there's the column numbers with the letter A after them. That tells you how many valence electrons a main group atom has. Transition elements, for our purposes, we're going to assume all have 2 valence electrons. That's because, remember, the S of the outermost shell is filled. So if it's 4s, then you get the 3d ones being filled up. These are your valence with the highest primary quantum number. That's why we consider the transition elements all to have 2. Okay, if we're going to draw a Lewis structure, we're going to represent our valence electrons as dots, and the symbol of the element will represent our nucleus and the inner electrons. We're going to arrange those dots around the element to represent our valence electrons. So the way we do that is first you write down the symbol of the element to represent the core, and then whatever valence electrons there are, you're going to put a dot. So lithium here has 1 valence electron, gets 1 dot. Beryllium has 2. We pair up the 2 for the s orbital, and then add around the other sides for the p's, and then start pairing up. So just like we would do, the S, and then that we would fill up our S and then do the P's. We're going to do the same thing, but this time we're using sides kind of a square around our symbol as the lines on our orbital diagram. So let's practice. Write the Lewis structure for the element arsenic. So arsenic is right here, element number 33. We're going to write our symbol for arsenic, and then it's in group 5A, so we have 5 valence electrons. We have our 2 4s electrons, and then 3, 4, 5 for the electrons in the 4p orbitals. There we go. And it doesn't matter which side you choose to put the 2 together. That makes no difference. Right, for ions, remember they're going to have the same electron structure as a noble gas. Cations lose their valence electron when the cation is formed, and so they're not going to have any dots around them. So here's lithium metal. Here is the lithium ion. You can just write the +1 charge. Anions are going to have the 8 valence electrons around them. And then to indicate the charge, we're going to put these square brackets and then indicate that it's a -1 charge in the case of fluoride. And remember from chapter 8, our metals are going to lose electrons to get the noble gas configuration. Our nonmetals are going to gain electrons to get the noble gas configuration because that is the most stable configuration.